This is the video notes for 1.4, domain and range. So what we're going to focus on is how to find the domain and the range for a given graph, a table, or a relationship. So the first definition we have is domain. So domain is the set of all the x values for an order that are given in a given relationship. So that could be a graph, a table, or a set of points. We also have range, which range is the set of all the y values for a given relation. So again, that's using a table, a graph, or a set of points. For example, if I have this set of points at the top, 1, 3, 4, -1, and -5, 6, if I was to turn that into a table, and you could leave it as is, but I'm going to make it into a table. If we write these out in numerical order, when we're writing this, we're going to use a curly bracket. And my lowest value is -5, so I'm going to list that first. I'm then going to list 1, and then I'm going to list my +4. For the range, we're going to do the same thing. I'm going to look at my y values. I can list these all out. I'm going to use a curly bracket again because I can list them. My lowest number is -1. We then have 3, and we then have 6. So that's my range for those given set of points. We can also write domain and range when it's an interval. So if we have more than just a list, we have like a large set of numbers that it's impossible to list all of them. So there's actually two different ways we can write this, interval and set builder, but we're going to focus just on interval notation. Set builder notation is something you'll see a lot more in Math 3 next year. So if I'm going to write for x is greater than 3, it's kind of like if I was looking at a number line and I had 3 with an open circle, and look at how it's shaded. I'm looking at all the values that are to the right, so it's going to positive infinity. So when I go ahead and list this, I can see my low value is 3, my high value is infinity, so I'm going to use a parenthesis, and it's going to go from 3 to infinity. If I want to write the interval for my y value, I can see y is less than or equal to 5. So I'm going to do the same thing if I was to do a number line with that. For example, I could do 5 with a closed circle, and I see it goes to the left. And so when we write this in interval notation, it's going to negative infinity because it's going to the left, up to 5, and we're going to use a bracket because it's a closed circle. For the next few examples, we're going to go ahead and see how do we find domain and range from a graph and how do we find it from a table. So for the first one, this is a linear function. We can see it has arrows in both ends. So that means it goes forever to the left to negative infinity, and it goes forever to the right to positive infinity. So for our domain for this is going to be all real numbers. So it would be from negative infinity to positive infinity. And then our range, we can see it when I go to it's going to go down and it goes upward. So it goes from negative infinity to positive infinity. For the table, we're going to do the same exact thing that we did above. So I have an x table, I have a y table. For our domain, domain is all the x values we can have. And we always want to write it in numerical order, but we also aren't going to write any repeated values. So we have here -1, 0, 1, 2, 3, 4, and 5. For the range, we're going to do the same thing, and we're going to make sure we have no repeated values, but we're going to put them in numerical order. So I see I have a 2. I'm going to write my 2 first. I have 2 3s, but I'm only going to list it one time. I see 2 6s, but I'm only going to list it one time. And then an 11 and an 18. Now, the other part of this question said determine whether it's a function. So if we're talking about a graph, we use the vertical line test. So if I draw a vertical line, it should only intersect the graph at one point, which it does, right? So you can see it hits all of these at one point. So this one actually is a function. And the same idea follows for a table. So for every one x value, it only should have one y value. So what we really look for in a table is that we have no repeated x values. And so this one doesn't have any repeat values, so this one also is a function. For the next example, we're going to do the same thing. So if I go all the way to the left-hand side, I'm looking at my domain. I could see on the left-hand side, all the way to the left would be -5. It's a closed circle, so it gets a bracket. All the way to the right is an open circle, so it's going to be a +5 with a parenthesis. I then see my lowest is, for the range, is -2. It's going to get a bracket. And then the highest would be 7, and it's going to get a bracket. For the next one, we're going to do the same exact thing that we did previously. So we do the domain and range. Oh, and actually, before we get to that one, you can see this one here. If I want to test if it's a function, I can see it passes, so this one would be a function. For the table, for question 4, it's going to be the same thing. So if I list my domain, I can see I list everything once. So I see -1. For this next one, I could see that. I'm going to list my x values. I'm going to start with my lowest value, which is -2. Then -1. I do see it 2 of them, so I'm only going to list it once. And then I have a 2. And then my range, I have -1, 0, 1, and 2. The question is this a function? I actually have 2 -1s, but they produce 2 different y values. So this one is actually not a function. For the next one, we're going to do the same thing. My domain, we can see, is it's arrows on both ends, so it's negative to positive infinity. My range, we're going to assume this is a 1. So my lowest value is 1 with a bracket, and it goes to infinity, so it's going to go up. And this one passes the vertical line test, so this one's going to be a function. For number 6, same thing. So arrows in both directions, so it's negative infinity to positive infinity. My lowest value, we're going to pretend that's at 3. So that's going to be a parenthesis because it's open circle, and a infinity because it goes up. This one also passes the vertical line test, so this one is a function. And then for the last 2, same thing. So if I look at my domain, I'm going to list it all out. It's already in numerical order for me, and same thing with the range. And then for if it's a function, I don't see any repeated x values, so this one is a function. And then for the last one, same thing when I go to the left and the right. My domain is -2 to 5. My range is -1 to 4. That's my high and my low. And then if I test if it's a function, it actually fails the vertical line test because it hits twice. So this one is not a function. All right. If you have any questions, you can ask in class, sign up for T-Bolt time, or go to the center.